Mr. Meek, can I say
Yep. So what we have here with the linear functions is the first thing that you need to know is that linear means line, which was probably common sense to many of you. That's what the prefix is, L-I-N-E. So we are going to be talking about creating and identifying and graphing straight lines. The equation of a line. The equation is y equals mx plus b. Y represents one of the y coordinates. X represents one of the corresponding x coordinates. Now, when you think of these x and y coordinates, what I'm talking about is an ordered pair, a point. Or in this case, a coordinate. Oh, wow. Adriana? Good job. The letter M represents the slope. And we've heard that word before many a times. And what's another word or phrase, Angelina, for slope? Unit rate. And then the cursive B, the last little bit there, represents the y-intercept. Now, the y-intercept is where the line crosses the y-axis. So the very last number in this equation is going to represent where that line intersects the y-axis. So we're talking about the x-coordinates, the y-coordinates. We're talking about the x-axis and the y-axis. We're actually talking about a coordinate plane. All of these equations will be graphed on a coordinate plane. So the first equation I'm going to give you is y equals 6x. And believe it or not, you've done this before back in September. You've taken a test on the I can statement that says, I can write an equation using the unit rate. And you guys found out that 6 hot dogs per package would be y equals 6x. 6 watermelon seeds per slice is y equals 6x. 6 hamburger buns per bag is y equals 6x. 6 kids per swimming pool, y equals 6x. 6 sunburns per Memorial Day represents y equals 6x. See where I'm going with this? Okay? Now, we are going to take this and we are going to graph this. Now, the first thing we have to graph is what's called the y-intercept. This number right here. And what number is right here? Zarar? This number right here is not a 1. Aubrey? 0.
Wait, didn't you say if there's not a number, what number would be 1?
I did say that when I talked about a coefficient. I said this. There's x. There's an invisible 1 there. If I go to distribute a negative to a parenthesis, there's an invisible 1 there. But here, there is no number. So I plot 0 at 0, which is called the origin. Very good. How would I write my slope as a unit rate? 247? Good job. Yeah. Good job. How would I write 6 as a unit rate? 6 watermelon seeds per slice. 6 cannonballs per jump. Kylie? 6 over 1 is correct. Now remember the song, y over x. The y goes in the numerator, the x goes in the denominator, y over x. Well, that's what we're still doing this. It's back. The song is back. Y over x. So the positive 6 represents the vertical change. The positive 1 represents the horizontal change. So starting at the y-intercept, I'm going to go up 6 because the 6 is positive. And I'm going to go to the right 1 because the 1 is positive. And then I'm going to connect my dots. And that is what the line y equals 6x looks like. Does this graph represent a proportional relationship? Zach? Yes, it does. And what 2 characteristics does it have? Very good. It's a straight line, passes through the origin. You have yourself a proportional relationship. If x is 1, y is 6. If x is 2, y is 12. If x is 3, y is 18. Again, we have no y-intercept. There is no number after the x. Therefore, we are going to start at 0, which is our y-intercept, the origin. Because our slope is already written in fraction form, I do not have to convert this into a fraction like we did number 1 to get y over x. I have y over x. I have my vertical change. I have my horizontal change. Now in this situation, my vertical change is -3. So I'm going to start at the origin and I'm going to go down 3. And my horizontal change is a +7. So I'm going to go to the right 7. And then I'm going to connect my dots. And that is what the line y equals -3/7 x looks like. Now, where in real life would we ever get something like that that decreases? This is a proportional relationship. Even though my line is not completely straight because I did not use a ruler, it is a straight line. It does pass through the origin. Where in real life would anything decrease? Aubrey. Taking money out of your bank account.
The amount of sales you have?
No. Jacob. Diving. What do you mean? Going underwater. Going below sea level. Taking money out of a bank. Very good. Decreasing in elevation. So again, to recap, I don't have a y-intercept over here, so I plotted at 0. Because my vertical change is negative, we go down. Negative numbers go down. My horizontal change is +7, so I go to the right, because numbers to the right are positive. Now, what's my y-intercept? Is my y-intercept 0? What do I have for my y-intercept, Timmy? 3. So that's where we're going to start. So right off the bat, is this going to be a proportional relationship? No, it's most likely 99.9% of the time going to be a straight line. But is this going to run or pass through the origin? Doesn't pass through the origin? No proportional relationship. Our slope is 2. How do I write that as a unit rate, Paige? Don't know how to write that as a unit rate? No, don't know? Ostrowski? 2/1 is correct. Unit rate means per 1. I am not going to start at the origin. I'm going to start at my y-intercept. My vertical change is +2, so I go up 2. My horizontal change is +1, so I go to the right 1. Connect my dots. Now the good old question that I just love to answer for all of you. Why in the heck are we ever going to need to know this? Why, Mr. Meeks? Why? Here's the example. Yeah. Yeah. 250. 254? Man, that's killing it right there. Here is a real life example. If you go to the Trenton Athletic Club over on King Road and 4th Street, you're going to hear this. A gym membership costs $200. So you pay the $200, you've got a membership to the Trenton Athletic Club. However, there is an additional charge of $4 per hour for daycare. I've got 2 little runts running around. If I need to work out and Mrs. Meeks is having tea, what am I going to do with my 4-year-old and 2-year-old? Option 1, I can leave them in my car while I work out and then get into a lot of trouble. I can have my 4-year-old babysit my 2-year-old. Zarar owes me now $275 for dropping my calculator. Or I'm going to have to bite the bullet and take my kids with me and pay $4 per hour for daycare. Now, let's say I work out for 2 hours. What's my total bill going to be? Timmy? $208. If I work out for a half an hour, how much is my total bill going to be? Jacob? It's $202 because I worked out for a half an hour. So we come up with the linear function y equals 4x plus 200. Our constant is the 200. That is never, ever going to change. Whether I bring my kids to daycare 0 times or whether I bring my kids for 100 hours. It's never going to change. It's always going to be 200. So let's say for a year I work out, there's 365 days in a year. Let's say half of that. Let's say I work out for 180 hours a year. At the end of my membership, how much money do I owe? $920. Now, mind you, just the membership alone was $200. And it could have been $200. However, I've got 2 little ones running around. That's costing me an extra $720. So remember that when, you're complaining about mom and dad not giving you a couple dollars here and there. Everything adds up. Now, the only thing I want you to do, and tomorrow I'm going to show you how to graph all these with these bigger numbers. I want you to come up with the equation. I want you to come up with the linear function for another real-world example that everyone should do at least once in their life. Go to Grand Haven and pick blueberries. You go to Grand Haven and pick blueberries. Admission is $3, and blueberries cost $1.50 per pint. All I want you to do is come up with the linear function, put your calculators away, and then you can get ready to leave.